Building an AI SaaS product means handling several concerns at once that are each complex enough on their own. The product needs a component library that produces a professional analytics dashboard without custom CSS for every chart and table, an AI orchestration framework for building chains and agents that handle multi-step reasoning tasks, production-grade patterns for deploying those agents reliable with retree logic and observability, access to Google Cloud services including storage, PubSub and Firestore for infrastructure the product runs on, and an uptime monitoring layer so the team knows when any service in the stack degrades. Without these layers integrated, the team rebuilds the same scaffolding for every SaaS product attempt, a generic UI, an experimental agent setup, cloud credentials wired by hand, and a monitoring gap that leaves incidents discovered by customers rather than the engineering team. With this stack connected from the start, the product launches with a polished interface, reliable AI behavior, cloud integration, and monitoring already in place. Tremor provides the dashboard UI layer. It is a React component library built specifically for analytics and data-heavy applications, with pre-built chart types, table components, stat cards, and layout primitives styled for business dashboards. The SaaS product uses Tremor components to build the customer-facing analytics views and the operator dashboard without writing custom chart code or CSS layout rules. Langchain provides the AI orchestration layer. It is a framework for building LLM-powered applications through composable chains and agents that call tools, retrieve context, and maintain conversation state. The product's AI features, document analysis, question answering over customer data, automated report generation, are implemented as langchain chains that connect the LLM, the retrieval layer, and the tool integrations in a structured and testable way. Agents towards production provides the reliability layer for the agent deployments. It is a collection of patterns and infrastructure code for running langchain agents in production with queue-based job processing, retree handling, timeout management, and structured logging. These patterns prevent the agent layer from behaving unpredictably under real user load. The Google Cloud Node SDK provides cloud infrastructure access. The product stores uploaded documents in cloud storage, queues long-running agent jobs through PubSub, and persists session and result data in Firestore, all through the official node's client libraries with built-in retry and authentication. Checkle provides the uptime monitoring layer. It is an open-source status page and monitoring tool that tracks the availability of the product's API endpoints and agent job queues, alerting the team and displaying a customer-facing status page when any component goes down. Following a customer's document analysis request through the stack shows the data flow through all 5 repositories and how each layer handles its part of the job. The request starts in the browser and ends as a completed report visible in the customer's Tremor dashboard. The customer uploads a document through the React frontend. Tremor's file input component handles the upload UI and progress display. The backend receives the file and writes it to cloud storage using the Google Cloud Node SDK, which returns the storage URI and confirms the write before proceeding. The interfaces between the cloud storage write and the next stage are the storage URI and the document metadata, file type size, and customer identifier, passed as a PubSub message to the agent job queue. The agent job queue, built using the agents towards production patterns, picks up the PubSub message and initializes a langchain document analysis chain. The chain loads the document from cloud storage, splits it into chunks for the retrieval layer, and runs the configured LLM with a structured prompt asking for the specific analysis the customer requested. Langchain manages the context window, the retrieval calls, and the output parsing. When the chain produces a result, the agent writes the structured output to Firestore under the customer's session document. The Firestore write triggers a real-time listener in the frontend, which updates the Tremor dashboard components with the analysis result without requiring the customer to refresh the page. The status indicator changes from processing to complete, and the result appears in the Tremor table and summary card components. Checkle monitors the PubSub subscription depth and the API endpoint response times throughout this flow. If the subscription depth grows beyond a configured threshold, indicating the agent worker is falling behind on incoming jobs, Checkle fires an alert to the engineering team's notification channel. The customer-facing status page shows the current health of each service component so customers know whether a delay is expected or anomalous. The build order starts with the Google Cloud Node infrastructure layer, since the storage, queue, and database must exist before any application code can write to them. Create a cloud storage bucket, a pub subtopic and subscription, and a Firestore database in the target project. Write a test script that uploads a small file to cloud storage, publishes a message to pub sub, reads it back from the subscription, and writes a document to Firestore. Confirm all three operations complete with the expected data before writing any application code against them. This infrastructure test catches permission and credential issues early. Deploy checkle next. Configure monitors for the API health check endpoint, the pub sub subscription depth metric, and the cloud storage bucket accessibility check. Set up the alert routing and the status page with the correct service names visible to customers. Verify that a simulated outage, stopping the API server, triggers an alert within the configured check interval and updates the status page correctly. Set up the langchain agent with the agents towards production patterns. Implement the document analysis chain with the LLM, the text splitter, and the structured output parser. The interfaces between langchain and the rest of the stack are the pub submessage input format the worker reads to initialize the chain, and the Firestore document schema the chain writes results to. Test the chain against three document types: a plain text report, a structured CSV, and a PDF. Confirm the output schema matches the expected format for each type before connecting the worker to the live pub sub queue. Security in this stack requires that the Google Cloud Service account key be loaded from an environment variable, never committed to source control. The Firestore access rules must restrict reads to authenticated sessions so customers cannot access each other's analysis results. Langchain tool calls that retrieve customer data must validate the customer identifier against the authenticated session before executing. Failure handling in the agent worker applies a retry when the LLM API returns a rate limit error or a transient timeout. After 2 retries, the worker writes a failure status to the Firestore document with the error type so the frontend can display a meaningful message. A fallback response indicating the analysis could not complete is returned to the customer, rather than leaving the job in an indefinite processing state. Configure tremor components last. Build the customer dashboard views against the Firestore real-time listener. The production deployment is complete when a document upload flows through pub sub, the langchain chain, and Firestore, and the result appears in the tremor dashboard without manual intervention. The documented configuration of each repository defines the SaaS product's capabilities and operational constraints. Tremor is Apache 2.0 licensed. Its documentation covers the component registry with chart types including line, bar area, and donut charts, the table and metric card components, the color palette configuration, the responsive layout primitives, and the TypeScript prop interfaces for each component. The project notes that components are installed individually using the Tremor CLI, and that each component's source is copied into the project for full customization. Langchain is MIT licensed. Its documentation covers the chain composition API, the document loader and text splitter configuration, the retriever and vector store integration, the tool definition format for agent tool calls, the output parser types, and the streaming response API for progressive output display. The project notes that langchain supports multiple LM providers, and that switching providers requires changing the model instantiation. Agents towards production is MIT licensed. Its documentation covers the job queue worker pattern for pub sub-based agent dispatch, the retry configuration with exponential backoff, the timeout and cancellation handling, the structured logging format for agent runs, and the observability integration with standard monitoring tools. The Google Cloud Node SDK is Apache 2.0 license. Its documentation covers the credential loading from application default credentials or a service account key, the cloud storage upload and download API, the pub sub publisher and subscriber configuration, the Firestore document read and write API, and the automatic retry behavior for transient errors. Checkle is MIT licensed. Its documentation covers the Docker deployment command, the monitor configuration for HTTP endpoints and custom metrics, the alert routing to notification channels, and the status page configuration with custom domain support. The fastest path to a working AI SaaS is deploying the Google Cloud Node infrastructure and running the langchain chain against one test document. With a confirmed firestore write from a real chain execution, the Tremor dashboard has real data to display. Which document type in your product would be most valuable to analyze automatically the moment a customer uploads it?